Okay, so LoRaWAN. What I've been working on recently is using LoRaWAN on the Things Network. The Things Network is an open network that is not very large in the United States at this point. It's really huge. Overseas in Amsterdam, they have full coverage with LoRaWAN. Here we have a few gateways that are deployed right now, but you have very long range on LoRa. So just kind of specs on a lot of modules, about 16 kilometers is what you can get. Now, a recent world record was just set using a balloon, and that was a point-to-point packet of 702 kilometers. And so with these technologies, the higher you can get your antenna, the more coverage you're going to have. And line of sight, obviously, helps out with that. A while back, we had, yeah, what's up?
So when you say 16 kilometers, is that something that you can sort of reasonably expect in some standard conditions, antenna on the roof?
To a degree, it depends on a lot of factors. A lot of that has to do with, I mean, a downtown area, no, you're not going to get that at all. There is a website I can show you here in a moment called CloudRF, and what it allows you to do is put the specs of your antennas and your transmitters and your receivers into this, and it will lay over a topographic map, and you can see, you know, a pretty accurate estimation of where your, you know, real-world coverage is going to be. We had a gateway, a layered gateway, an 8-channel LoRaWAN that was installed on the 34th floor of the Louisiana building downtown, and did some war driving in the downtown area to, you know, collect data and get, you know, real world. This is exactly what we're getting. We threw that into CloudRF, and then we can export with KML files and pull that into Google Earth, and, you know, see within Google Earth exactly where the coverage was estimated to be through CloudRF, and then what actual readings we were getting as we were war driving around the downtown area. And so we kind of correlate those two data sets. And from what I was able to see, and I didn't have a huge war driving data set just because, you know, driving around downtown at different times, it got kind of old. So, but it seemed rather accurate with what I was seeing.
Would you use that or as an estimate, or like if you were doing a project, would you feel comfortable enough to use that as an estimate?
That's what I would use. Yeah, that's what I have been using, and I would love to hear about, you know, other systems. And what this is, it's commercial, but it's very cheap to use. And I guess you pay for a monthly subscription. It's like under $10, and then you can just run as many calculations as you need, you know, for different transmitters to see, you know, to add to a map on your coverage. Now, there's also an application, and here, let me kind of get moving on this a little bit, and we'll hit that here in just a second. So what is LoRa? Now there's LoRa and there's LoRaWAN, right? And LoRaWAN is going to sit on top of LoRa, and that's going to be your messaging transport, right? But in general, it's a very low speed, long range, very low power consumption wireless technology. 15, 16 kilometers, like I say, is what a lot of people are quoting. But we're talking 50 kilobits per second, which is very tiny. This isn't voice, this isn't video. This is if you have a sensor that you need to take an occasional periodic reading on, is, you know, the primary application of this technology. Now, it's not just the 50 kilobits per second that you're restrained by. You also have your rates of sending and receiving packets are limited. Now, it's a little different in the United States as than it is overseas. And Syntec owns LoRa. It's proprietary, it's patented, and the radios that they provide are integrated into a number of modules from different companies, right? Now, some of these modules have an integrated stack on the module. So it's kind of like an all-in-one, you know, easy to integrate and into a product, right? You can also just get more of a stripped-down radio, and then it's up to you to implement that stack on your device. What's up, man?
So that, but when you get a radio, the licensed technology and everything, it's all in there. You're ready to go.
Yes.
There's no licensing that you have to do.
That's correct.
Outside that.
That's correct.
Okay.
There's no airtime fees. Now, if you want to add on, you know, commercial server or of course, you know, those are different products, and that's not directly related to
Yeah,
what we're talking
but we're
about.
talking about specifically the wireless technology.
Correct.
Yeah. Okay.
How does that compare to Sigfox?
I'm going to defer that question to the guy that does Sigfox over here. Jorge?
I mean, in terms of, there is he was talking about a 50 kilobyte limit, and also in terms of, you know, range and coverage, you know, how does that,
They are kind of the same, but different. Like, as Travis said, the Centec chip is owned by Centec, so
Right.
it's their technology.
they're both LoRaWAN, right? No.
Yeah, it's a low power network of
Yeah.
Sigfox. But Sigfox just released their stuff to anyone that wants to make chips.
Mhm.
So it's kind of like,
Not open source and now they're open
yeah,
source.
not free, but
Different licensing structure.
yes, Sigfox, you cannot do your own network on Sigfox because the Sigfox concept is that Sigfox is like AT&T. Right. They provide a network for you to connect. They provide the support for the network to be up. Pretty much.
And you pay them
And you
to
pay.
use their network.
Yes.
Yeah. So, but, you know, and this one, the one you're talking about, right, is, you're talking about LoRa, but you were speaking before about the Things network.
Yes.
So I'm thinking that Sigfox and Things network are similar competitors or something like that? No?
No.
The Things network is not, they don't maintain the network like.
It's open.
Sigfox?
So.
Well,
It's more of a,
It's a Sigfox kind of like your gateway plus things network.
is independent.
well,
of
you
who
don't
they are.
own the gateways with. I mean, with Sigfox, you don't own them.
Yeah.
With LoRa, you put up your own gateways and you become part of the network. And that's actually what the Things
Gotcha.
Network. They say you are the network.
Yeah.
You know, you are building
Thank you.
The
into the network.
function wise,
Like,
Yes.
it's the same, right?
Once you
Yeah.
get on to a network,
Um,
internet.
we're talking the same
You do anything
frequencies.
after that.
Same
roughly. I mean,
frequency,
it's-
low power.
Right.
and
More or less.
Technology.
Same characteristic, like low power, low range.
Whereas one, you would set up your own network versus one, you would have to just have coverage. Right?
But even if you set up your own network, by going through the Things Network, you,
Right, you can
have
then
use
use-
of everyone
Yeah.
else's
If
gateway.
someone's near you, that is also
Yes.
doing it. So you get
When
your
I
neighborhood
beacon-
on board and you can all,
Community network.
yeah,
Yeah. Yeah. Pretty much.
exactly.
And so when I beacon from a node sensor, multiple gateways will pick this up, right? I mean, if they're around.
To that
And-
point, can you set up a private network where you don't?
Yes, yes you can. Now, part of the structure with the Things Network is changing with the next release, which will be coming in about 4 months right now. And that will allow you still to run, I mean, it's open source, you can still run a completely private server, but in order to route across the Things Network, but you don't want to share your resources, then there will be some fee structure at that point. Okay. So, all right, we're talking about low power, long range. LoRaWAN, this is the messaging protocol, the stack that pretty much sits, this is the layer that sits on top of the physical layer of LoRa, right? That's all we really, I'm not going to get too technical in this talk. I want to talk more about implementation, and I want to go over the Things Network, and I can do an end-to-end walkthrough, you know, from a device all the way through to a dashboard. And so you can see kind of how the workflow goes to set up a project here. Okay, so this is what our architecture looks like. I mean, I guess we've gone over most of this. We have our end nodes, we have our gateways. You have your servers, and
Because I think some folks in the back.
What's your cable over there?
Yeah, you might not be able to do that more.
Is that? Can everyone see that?
Maybe you standing on this side, maybe better.
Cable with wires on it. Long.
I think that's good, if everybody can see. Sorry about that.
That's fine. And, okay, I'm sorry, this is encrypted end to end. So from the node all the way into your back end, if that's a cloud system, whatever, it's encrypted. Your data is yours. You can run 10,000 devices on a gateway. And by that, we're talking about an 8-channel LoRaWAN gateway. And that's what most of the gateways out on the market that are true LoRaWAN gateways, they're 8 channels, right? Okay, we use different frequencies in different countries. In the US, LoRa is on 915, and Europe is using a different country, different frequency. Now you have to have a different radio for these two areas, and so when you're buying radios, you have to be very careful you're getting one for the right zone that you're deploying these products to.
868 euro.
Now, yes. Now, there are other differences as well, and this has to do with your spreading factor, with the rates that you're allowed to transmit, both ET and the power that you can transmit. I've got some of those for these two regions outlined here. And you'll see that we have a difference in the channels. Where this says 6488, those are not all used, and a lot of times you will trim down the group of channels that you're using. And so if you are building up a module, and because it's so, it's really exploded in Europe, you have to make sure that you implement these changes if you're working on an open source project, if you're deploying in the US. We can also run a lot hotter over here. So this is your spreading frequency.
What is spreading frequency?
What this is depending upon what number I have, I can either have a shorter range, but
Number of bytes that you can send.
yeah, well, it's I think I'm thinking if I had a slide on this. Let's see.
If it's spread spectrum technology, it has to do with how.
It's spread
It's spread,
spectrum.
yeah.
I thought I had this.
Is that
Now
data
it's-
rate per channel, or is that total?
Pardon me?
The data rate, is that per channel, or is that the total for all the channels combined?
No, that's for for a message on a channel. Does that make sense? Because
So-
I'm only sending on one at a time, but I'm going to be hopping around channels, right? And so I may miss a join connection when I'm trying to connect to the network, right? And so I just try again. Now I can have different classifications of packets of uplinks, right? And these can be one that it's fire and forget. I don't care. I don't need to know anything about it. It might work, it might not. And I can also get back. If I don't have an acknowledgement, then I go through a retry. And
Similar like QoS and other systems,
Yeah,
like quality of service.
well, to a degree. I mean, it's a simple acknowledgement, really. But I'll go through the packets that we get back, and we can look at a payload. But depending upon your spreading factor, this is exactly what you were saying. And this bottom part, battery life. It has a huge, huge bearing on battery life. Okay, at this point, I have a gateway set up over here. This is an 8-channel LoRaWAN layered gateway, and it also has Wi-Fi and Bluetooth on it, but it's opened up, and you can take a look at it. It's using my cell phone as a hotspot for the backhaul, and just linking onto that, and then we're going to go over to the Things network, and we're going to go through to some back-end service. I'm not going to play that by ear. We'll see. Layered. They are relatively new into the LoRa components. This is a development kit for a layered module, and the module is just this postage stamp size thing over in the corner, right? Everything else is, I don't know, you have an Arduino shield connector here, so you can attach anything for the most part that works on Arduino. You can, here's just a 16:2 display with a keypad, right? And you can stick this on, and you have to do a little bit of wiring around, which wires it into the module. But you know, you can integrate that directly. One thing about this module, it doesn't have its own built-in pull-ups, so you have to have external pull-ups if they're needed. Just an FYI. Never run anything that's transmitting without an antenna on it, or you will burn it out. When you deploy, just on this device here, it's under $20 American. So that incorporates your some power management, your antenna, and so it is really a standalone module. Now, yeah.
In the sense that it can be programmed, or
Yes, and I will show you this, and that's what I'm doing now.
Okay.
I can show you right now.
not fun.
Well, actually, let me talk about it. This is Microchip, and this is their version of Microchip, okay? And it's a different company, it's the same type, and this has, you know, it's licensed with Simtech to use their radios and their LoRa system. So this is just another little test system. And then this would be the equivalent of Microchip's, this is their gateway, which is an 8-channel LoRaWAN gateway, like what we're using over here by Okay, device classes. Pretty much everything will support Class A. And that means that my device is going to sleep and save power as much as it can. And then it's going to periodically send messages up. Now, after I send an uplink, then there are 2 windows. And during those time slots, I can listen to see if a downlink is being pushed to me. But I'm only listening during those windows. I'm not always on awake listening for a signal to come down. And so anytime I transmit, you know, I listen and I can receive data at that point. And that's the difference between Class B and Class C. So Class C is where the network can push packets, and the device will respond to those, right? Anytime, there's no windows on it. But, and there's applications where that's you know, critical for it. But you do not get the power that you're,
Yeah, you have to. The radio has to be alive all the time.
you pay for it, yeah.
Right.
So,
So you said Class A is the device itself has some sort of wake-up mechanism to communicate with the network, is that what you're saying?
Yeah, you wake up, and you can wake, I guess, interrupt-based or, you know, whatever you want to wake up and say something, yeah, that's fine. Or that could be, you know, event-based with an interrupt, that could be timer-based, however you want to implement that. The Things Network. Building a decentralized, open, and crowdsourced data network that anyone can use, it's free to use, anyone can set up a gateway and build into the network. And the prices are coming way, way down on these gateways, so that's great to hear. Okay, these are some communities. This is the Things Network, and there's more now. This is an older map. You can see the Things Network recently released their hardware that they did a Kickstarter for. And so they actually make their own gateways and modules now. And they are actually out there in the wild now. They finally shipped. And Avnet, you know, built these up. I don't know if I have a picture here, but I mean, I can pull it up.
There's no coverage in Iceland. Dadgummit.
I do, like I said, a lot of AWS work. This is kind of how that fits in with the AWS IoT system, how this integrates with you know, the front end. But it makes it very easy to, you know, once you get this in through AWS IoT, if I want to act on any event, coming through, I can do anything in AWS that I need to. If I need to send a message, if I need to, log that with CloudWatch, if I want to run a Lambda function, I can trigger all of that, no problem. And then everything uses AWS IAM for user management. This is just kind of an overview of, you'll have your end nodes, and everything doesn't have to be talking to the system the same way. At different points within this transaction, I can have a sensor that is going through Bluetooth, that comes into my system. I can have, you can really...
This is for the things, specifically for the things network, or?
No, this is just kind of in general for IoT.
Okay, yeah.
When you're looking at a full solution, you're not necessarily bound to a particular type. For example, I mentioned the backhaul here. I was just using my cell phone. That could be using, some other technology. That could be, I could have another gateway that uses Bluetooth, and then its backhaul is LoRa, and then the LoRa's backhaul is narrowband IoT or LTE or a different technology. And so I think it's important when you're thinking of a full solution, how you can have different segments, and you don't have to use the same technology across the board. This, okay, I've got a few slides here that talk about different technologies and kind of how they compare within the range and data rates. And so we have like our narrowband IoT, Sigfox LoRa. That's going to be our long range systems. Then you go over, and as you go to your fatter systems, especially with cellular, your data rates go up, but so does the pricing in order to deploy and maintain, because you're not running your own backbone there. You're not running the gateways. You're not running your own architecture. This is another rundown. If anyone's interested, you can look at this later. It compares the different technologies here. Okay, that's my slides. I wanted to do a walkthrough now. Are there any questions about any of that? It is it is encrypted, the things network natively, and so you don't have to encrypt, but you can encrypt. You can run. There's no particular established format for your payloads that you're sending, and so you don't have to adhere. I can pretty much throw whatever I want out, and so I can use my own encryption. It doesn't matter, but.
If I want to encrypt and I don't really have, don't have my own message encrypting, will it do it natively?
Yes.
Right. So if that's good enough for me, I can just use what the Things Network supports.
Absolutely, and I'll show you how that works.
Just to say we'll listen to it anyway.
Well, in Amsterdam, they got full citywide coverage with 10 gateways. And when we're talking about what $280 for a gateway? To have full, the city of Amsterdam covered, that's very, very cheap. Right? Now, what applications?
Yeah, like what cool projects have you seen?
There's some neat ballooning projects.
I heard of a parking system that you can subscribe to mobilely, and it'll direct you to open parking locations.
Yeah, that's cool.
I've heard of that. Now, I don't know if that's specifically using LoRa. I don't know. It was a while back, so I'm guessing they probably did it, implemented it in a different way. But I see them doing things like that. With this technology, it becomes even less expensive.
Measure water and trash cans levels, measure water levels on tanks, on buildings, sort of stuff.
Is there a cost associated by using it, or it's just completely crowdsourced?
Free. Well, you're running your own equipment, so it's
Correct.
You're in an unlicensed band, so yeah, you pay to charge your batteries and you pay for the equipment.
So the part that I don't understand is, if I'm using my own equipment, what's the benefit of, where do I connect to? Is there any points? How do I connect to the internet?
You have a gateway with a backhaul on it. For example, like anything within what a 16-kilometer radius right now can, you know, send their packets from wherever they're at.
Correct,
And
but
this will route it out to whatever application they have that device associated with.
So what do you say? No, but okay. So I think
No,
I'm
the Wi-Fi.
asking a question about the.
How it gets to internet?
I'm sorry.
How your package gets to internet?
So you don't have any gateways. You just have you develop something with nothing but LoRa gateway nodes, right?
Okay, okay.
How does that data get out?
So versus the thing network. So my thing is the thing network is crowdsourced, right? Is that what you said?
Okay,
The
it's
thing is just a message.
You get the
router.
gateway first. The gateway routed through Wi-Fi or Bluetooth or connected to your computer, right? And then you go to the network.
and then it can go
Yeah.
correct, and then it can go to the Things Network or a number of other
Right.
LoRa networks that have different application servers and authentication, you know, servers for those particular
You
brands.
need an
or-
internet hookup to that gateway. Pretty
Yeah.
much, you need internet.
Now,
You get it 4G or
But the guy who owns the node, the
Needs to pay for
receiver,
it.
is paying for the internet connection.
That's what I was asking.
Yes.
So the Things network really is basically volunteers giving bandwidth to the internet. Is that what's going on?
Yeah, because it's gonna be low bandwidth, that.
Very low bandwidth.
you're
so
not
even
going
if
to
you
notice
had-
it if you
Yeah,
have it.
yeah,
Okay, got it.
If you had one in your house and you
Yeah.
were allowing it to go through
Sure.
your broadband,
yeah.
you couldn't see it, like compared to Netflix. It's like,
Right,
you
yeah, a
know,
little kid with the tablet's gonna do way more damage.
yeah, lots of
And
Gateway receives everyone's messages, but it's using your own internet connection to get it to the server.
Perfect. Thank you. That's it.
Well, something else to be said here is the subject of liability. Like, if someone is developing some type of medical or you know sensitive application, you don't do that with LoRa. It's not the technology that you're wanting to use for that for any life-threatening or. But all of the data coming through my gateway. I can't read it. It's encrypted, and so there's no liability on my part for if I just unplug my gateway, or, you know, if I just take it off the net, if I pull it out of the Things network, and everything will just be routed. You know, if it can be routed through different gateways. But if this is the only gateway in the area, then just you're out. There you go. So. All right. So what we have here, let's start. Okay. What this is the web interface to that layer behind me.
the gateway.
The gateway, yes. So I'll show you how we can select the different networks here. So you can see on this gateway we have, this is just the, what an Ethernet cabled connection at the bottom, which is disconnected. I have my Wi-Fi up and I have my LoRa connected.
Can you bump up the font size?
Yeah, I'm sorry. Yeah, absolutely. Is that better?
Yes.
Now we can read it.
All right, cool. So these things are very easy to set up. And in the new firmware that they released like a week and a half ago, they now have a quick Wi-Fi setup. that allows you, you don't have to actually plug the thing in to configure it now. And so what I'm doing is basically getting the last few digits of the MAC for the gateway, and then running it local, which, you know, using Apple Tech allows me just to call it that, whether I'm connected at my house, onto my phone, whatever. So this is what it sees, and I can associate this with any of these, you know, hotspots, right? So then I can save those off to a profile. One thing it doesn't allow you to do is waterfall, which I don't know why they didn't include that. So I have to actually go in here and activate a profile. I can't have 3 active profiles and waterfall down until it catches one. That's ridiculous, especially when you're dragging that thing around, you know, with you. So one thing they added recently in this new version is a traffic or LoRa, so I can actually go through, pull, and see the traffic coming through the gateway. We will come right back. So that's the gateway. I mean, there's other stuff that it's not really important right now. Now, this is the things network, okay? We have, right now we're going to go over gateways and applications, okay? These are a number of different gateways that I have. Some are single channel, some are full 8-channel LoRaWAN.
May I ask, is this a view into your own things, the Things Network account?
This is his account.
Yes.
So if I were doing it, I'd be different, right? Different gateways and things, right?
This is Darko's gateway.
Okay.
So I can share, you know, certain,
okay.
you know, there's levels of access that I can share with other people, and then those show up in their dashboard or in their console. Let me come right back to that. This is the gateway that we have right over here, right? Now, what we have some keys that okay. And
Dark quiz.
so
Well, I know it anyway.
where that was.
Yeah, you can pass it.
Go ahead. So this is how I can set, you know, at least at this level, you know, the privacy rights on those open. But this is just a traffic rundown, and you see, okay, this would be a downlink, and this is an uplink, okay? So if I look at this uplink, I can see my actual payload. If I look at what my payload is, it's encrypted. I mean, there's no way I can know at this point.
G-A-J.
All right.
Yeah, no, I could read it, I'm just saying.
But I see what's spreading
that
that
means?
that this payload came in with. I see the bandwidth and the airtime. And then I get my quality. And we'll go back to there in just a second. And my device address, okay? Now we're going to jump over and look at applications. Applications, this is where I could say, okay, this is an app that I'm running, and I'm going to do...
Can you explain a little how application is connected with signal that with message that came into?
Absolutely. That's what we're doing here. We initially just name an application, set it up, right? I'm going to do something with this application. And then I generate some keys. And then I associate devices with this application. And so I go into this device.
You choose the application in the Things Network?
Yes, yes. And then I would, let me go down to, okay, this guy. This is that card sitting right here, okay? Or that layered module. And so I have a device ID here, and then I have these keys here, these EUIs. And I am going to need all of this to chain these devices to my application through, so we can go end to end. So what we can do now,
That's how it's identified.
Yeah,
Yeah,
that's how one end is tracked. So I have my app session and my network session. And our devices are linked to our applications. And that's how we're going to pull this data through. So, oh, this is also just a test console, so I can throw test uplinks, you know, from the Things Network to and from devices. And then I can actually see, you know, this is what you're going to use in your code, whatever you write your application in. You're going to need these two keys, right? So what we can also do, this is kind of neat. we can go to integrations. And these are just out of the box built in. So I can have data storage, which gives me 7-day storage of all data, right? And then I get this a little larger, these endpoints. So I can query my devices, and then what I do, I authorize myself on here, right? And once I'm authorized in order to use that application's endpoints, then I can just call a GET. So I can get devices, I can look up a particular device by device ID, and just see the data that's been stored in the last 7 days that's come through there, which that's very neat. What we can also do is, this is actually probably a good demo. This is, what is it going to do? Allows you to build a very simple like dashboard, okay? And send data from a device through your gateway, through the Things network, and go into this mydevice.com Cayenne site. And rather than this, we could set up a full AWS setup and do whatever you want with, on Amazon's cloud. The same with Azure, the same, with any type of backend that you're wanting to interface with. I think this is a good example just to show workflow from device and how everything moves through. Let's see.
Hey, Travis,
Yes.
generally speaking, is there an assumption that the outgoing sensor is static in one place, or can it move?
No, not at all. You can be sending GPS data. I mean, that could be part of your payload, or actually just associated with the payload if you want. You can be tacked on to to what you're sending up. And a lot of devices, like that one device I built with the switch on it that I was doing the war driving with, that had GPS in it, and that was,
That's how he maps.
Yeah.
How far?
Now, I'm glad you brought that up because there is another project called TTN Mapper. And what this does, you load the associated program onto your phone, and then you bind that app to a device. And so even if the device doesn't have GPS on it, it uses the GPS on your phone, and your phone, it links that GPS to the device, send and receives as you're driving around. And then I can pull it up online and see where I just went, and see all the data that came through that. I can set up I can set up an experiment on TTN Mapper, and that means don't push this data into the public. This is just my own private little thing that I'm testing with. Otherwise, it helps, if this is cool to push the data through, because it's not going to be any private data. I mean, basically just location and signal strength. That helps the network display to anyone who's curious, what the coverage actually realistically looks like, in real world situations. So.
Travis,
Yes.
what if the device leaves the network? Can I store that data on the device and get it back when it jumps back on the network? Will it jump back on the network?
Yeah, you can do something like that. For example, if you don't have a gateway in range, but I'm still sensing on my device, I can write to I've got a device over here that has a micro SD card on it.
It would be application specific though.
Sure.
Like you would be
Absolutely. No, that's going to
it'll
be
be on
within
you.
your application. So, and we can look at some application code here in a bit. But, and you can write that.
You would have to use Class C though, because if Class A you just fired off, you would know whether or not there was a network there to receive anything, right? So when Class C would tell you that,
No,
hey,
no,
it
Class-
Waiting on acknowledgement, right?
No, because, okay, I see what you're saying. Class C is staying open all the time for downlinks, and that's not what we're looking for here. We're just saying if I don't get an acknowledgement from an uplink,
oh, okay.
and I keep retrying, I hit the end of my retry cycle, then I am going to start storing those locally into, some data structure onto some device, and then periodically, and probably slow that rate down,
Right.
but periodically try, and once I do get an act back, then I would start running through that queue.
I see.
Yeah. So all of these are real world gateways. So we're gonna see what they find in America. Okay. Yeah, these aren't up to date at all. This is just basically who's been doing testing through TTN Mapper recently. And you know, as you found out, Darko, this is not it's not real time by any means. But you can get some interesting information from this, and there's different modes. But it's for coverage area. It's for looking for particular tests to evaluate where the coverage of your gateways lie. While we're talking about this, let me pull up. All right, so this is the interface. I think oh, I wiped all these out here. That's smart. Okay, here's a few. Let's see if we can get something out. Okay, so this is just, this would be one test I was running at a particular transmission power. And this is laid over a neighborhood, you know, where your coverage is for that area. And you can link these together. You can have different different transmitters at you know, different configurations to kind of see if you were to test different antennas out. For example, Darko picked up these antennas that when you modify obviously your gateway, you change things in here, and you can see, you know, play around with different antennas or different specs on antennas. You know, going through Mauser online, looking at specs, and kind of seeing how a particular antenna would maybe, you know, affect your coverage. What's that?
Might be worth the upgrade.
Yeah, exactly. But you know, like you said, antennas are kind of voodoo, and there's a lot that goes into them. So.
Can you change the height in there so we can see the difference?
Yeah, let me go over to antenna, and you can go through. Yeah, and they have a ton of different, I guess, spec'd antennas and types of antennas.
Yeah, configuration.
Yeah, that you can go through. They have a library, or you can just go through and completely make your own. And, yeah, I can do that. Basically, it's going to get bigger if you increase the transmission.
15 degrees for 14 miles.
I mean, we can do that, but it's just going to have a little more of green, and we'd have to go through and run the calculations. But, okay, so that's you know, some mapping stuff. This is AWS IoT dashboard. Just if you're familiar with it. You use, the way AWS handles things, you have something known as shadow states, or shadow devices, and if a device loses connection to your system, then anything that's querying that device looks at the shadow state. And when this device comes back in, you know, to your system, then it reconciles the shadow state with the device.
Like shadow, like you mean hold like is it like holding the last reading or?
And you can do your own syncing logic. I mean, you can get down to the sync logic if you need to there. But you can integrate TTN directly with a two-way sync directly into AWS. And it's not difficult to do, which is very neat. That means that I can go ahead and onboard a device either through TTN or through AWS. And that will reconcile itself. So, and if I need to onboard a bunch of devices at once, or you know, if I'm doing like a fleet and I need to do that, I can. There's methods that make that very easy to do. So what we're going to do now is we are going to look at this little layered module right here. Okay. Let me pull up some code for it. Okay.
What kind of code is this, Travis?
Well, it's a few different kinds. I'll show you. This guy right here is an ESP32. And we can connect, I've got code for this. It's got a little OLED display on it, but it doesn't have an antenna. I've got one somewhere. But I've got code for this. Any of these, like Wemos, those are, just little ESP8266s. And then this is a shield that has an RFM95W module chip on it, and that's your actual LoRa radio, right?
That's small.
Yeah, and they're difficult to find, honestly. You typically order those out of China, and otherwise you're going to pay about $20, $25 for one, as opposed to $5. And there's not a lot of companies you can get. And then this just has some RGB LEDs, a button. I mean, it's just like a little test shield. But a neat thing here, you have three diodes that actually allow you to share one data line, so you're not using up, you don't have a lot of I/O, these tiny little D1 minis. But yeah, the code for those guys. Now, we'll look at that in just a second. Now, the code on this uses something called Smart Basic. Smart Basic is an event-driven language that actually kind of makes sense, because on the layered modules, it handles all of the LoRa stack for you. You don't have to get down and have an implementation of that yourself. It's handled, by on the module, as opposed to these Wemos. Those are Raspberry Pi Zeros right there, and that has a shield on it with the same RFM95W radio on the left, and then just a little OLED on it. So if we want to look at the code for those, we can do that. And those are just coded with, just an Arduino sketch. There are a number of repos that have been developed, and a lot of different branches, forks of these, to handle that radio on different platforms. So let's see if I can make this larger. But it's very straightforward code. You
There's
just
a magnifier in the top right up there.
Okay.
Oh, that's the serial port.
Oh, that's the serial port.
Control plus.
Yeah, I have control. Well, I have control upping. I don't know.
It's the Arduino IDE, remember?
Yeah, I don't remember. That's
Yeah, okay.
Our preferences and font size is somewhere in there.
Anyways, I'm not going to go through the code anyway, so, but you can look at it.
Well, it's code, great.
It's code, yeah.
Very good,
But
Travis.
no, what I'll do, like for example, I wanted to go over it. This is actually not node code. This allows you to run a single channel gateway. And so it's not LoRaWAN, but I can say, all right, I'm only going to listen on this channel. And I'm only going to listen at this starting frequency. And so if I have other devices, as long as they know how that guy's listening, I still get the range of LoRa, right? I still get the low power consumption here.
Are you saying, but it's not like a general purpose gateway?
It doesn't meet LoRaWAN specs.
Okay.
And it's just one channel, and so you can get things coming at the same time. You can, and if I'm pushing a downlink, that blocks all uplink channels, right? And so there are ways to miss messages, and the Things Network especially, they don't really advocate people making a lot of these single channel gateways if they're not explicitly listed as a single channel, because it's not something that I can route data through. It's not really a true gateway. It's not much use to anyone else on the system as far as routing traffic is concerned.
If you want to build your own
Yeah, absolutely.
satellite devices.
Now, beyond that, I can just talk LoRa, not LoRaWAN, and just go device to device as well. And I still get the range there. So.
And you're not limited to any data.
No.
Except for the bandwidth limitation of the actual platform.
This is what's interesting.
You're on time.
This layered, It has a lot of downlinks in the demo code on it. Let me pull this up. Oh, I've got a screen right in front of you.
They do that too.
Oh, that's a lot more. So just take me a second.
The party.
Sorry, guys. There we go. So this is some of the smart basic, and let's jump. Yeah, that guy. Okay. Oh, smart basic. This doesn't have syntax, so. But I can make it bigger. So.
All right.
So what we're doing here is we're going to put this code over on this board, all right? And this is going to target, since this is kind of dragging on a little bit, we're not going to do an AWS integration. It's very easy to do as well, but we're just going to integrate with that dashboard. So what we do is we just use a terminal. We're going to use AT commands and see what's on this guy. What we have to do is run these commands that will store a non-volatile, I say non-volatile memory. I can reboot with no problem, but when I delete an application from the card or from the module, then it wipes out all of my device data. Now, the other thing, if I can't overwrite the same application, it just keeps building up, and so you do have to go through and wipe it out. And so they have this thing called automation where I can just set up, and then I just click, 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 and that just burns it back down into the non-volatile. And then we can say, all right, let's cross-compile, load it, and run it. And we're loading up this piece of code right in the background here.
What does the code do, Travis?
Oh, okay. So the file system's full, even though we're just overwriting that same thing. So what we need to do at this point, we get back and we say, okay, we need to AT %F. Let's just, I'm just going to blow it up. Oh. Okay. What this code does? Really? Okay, so we're going to put these settings back onto the module. Then reset the module. We're going to cross-compile, load, and run. And what this is a simple basic program that will read certain sensors from this development board. It reads the state of this button, which will control this LED. It's just using some of the sensors. It's got a temp sensor on the dev board up here, and it sends that value through, and it allows me to push states from the dashboard, like back down, or those down links over to the device. Okay, so when you put that on, I don't know if I can make this larger, but it's attempting to join the LoRa network, right? So what we can do is jump back over. And you notice that this application is called AWS TTN application. I have this tied in to an AWS IoT backend already. But if you notice, what I did is I just added an integration to support this Cayenne, right? On top of what I'm doing with AWS. So we're just going to tack this little dashboard onto that guy. And so we come over here and,
And is Cayenne just for dashboards, or?
It's generally not held in super high regard in my experience, but it has a defined like payload structure, I guess, of the data that they expect on the back end, and so you have to fit your data into that structure.
But the cool thing about Cayenne is that supports TTN, like, it supports TTN just like out of the box. You don't need to do any configuration, anything like that.
So, now, that's just the timeout message. It sounds forward. So if we look at our data,
There you go.
this is on the device. This is on the RM191, which is the layered module. And we can see our times. Can you see it? We can see our timestamp. So we can see the payload. And this is broken out in fields for this Cayenne, right? And so you can see that these have named fields for the temperature, for example, and that's the temperature in here. It feels warmer to me. But
23. What does 23 mean?
well, yeah.
Like that one?
Exactly.
It's a real temperature.
Real temperature?
Actual
What
measure.
does that mean, real temperature?
And so this is what we're pushing up right here. This is the metadata that accompanies. So we have location data that is tacked on in addition to our fluid. And all of this is going through. So there we go, 23.6.
And that came from just current reading and everything, huh?
Yeah.
Nicely done.
Push the button.
Yeah.
And you can see that same thing on the gateway backend, right?
Yeah.
You have to hold it.
Oh, you said you can change the state via the test UI to do it to send it downlink to the device.
Yeah, let me show you that.
You can turn that with
Crazy, man.
Morse code,
Yeah, I mean, I didn't say
Put the
like,
pressure on.
say animated or.
Come on, do it. Do it. Do it.
All right.
See the confirmed and unconfirmed? If something's unconfirmed, I'm not going to wait for a confirmation and then do a retry on it. If it's a confirmed packet, then I will trigger a retry in those cases. So yeah, we can see this is looking at the gateway. Our payloads. And let's go back over here and the way this is set right now for this button is only when it's pulled it sends the state of the button. It's not enqueuing those. So I'm going to hold this. Hopefully it's not for very long. I think the holding is pretty good.
We'll find out.
Yeah.
You want me to come hold it for you?
Hold on back.
Put a book on it. Put a book on it. Oh.
And then,
Oh. There you go, Ryan.
so that's pushing data down.
Oh, yeah?
Well,
from
we don't
the-
see it. We don't see it.
Well, it worked, okay? So yeah,
Trust it. Verify.
but like I say, that's the same process pretty much that you go through. Like if you want to do AWS, you're going to put together a cloud formation. Script most likely that will go through and deploy the different services that you need to get that up and on your AWS, and then you can do whatever you want with the data on the back end. If you want to send messages, store it into a NoSQL like DynamoDB tables. If you want to run that through a rule system, which is integrated into the AWS IoT, you can do that and operate on these rules. If I want to run analytics with like Kinesis or some system on AWS, I can operate on the data. That's my data. I can do that, and it works pretty darn well. So, my computer's dying. So, is there any questions?
Did you say that in Europe the network's getting congested, or?
Yes, but they have things in play to get around that, and that's where your data rates, those limits come in, where you can only use a certain amount of airtime per day, right?
Okay.
And now this is per node, okay? It's per device, and the gateways don't have anything to do with it because a gateway will route whatever traffic it hears that is being routed properly to an application. Now, if it can't find a route for something, then it just doesn't know. It just drops those packets coming. But
Sir, can you see like packet launch, or is that just kind of?
yeah, you can. If you go to your gateway, you can see if it drops a packet. If something's coming in, you can see the manufacturer. I mean, you can see what systems that you can get a little bit of information and see how you handle it and see if that's just dropped. Now, one thing I don't like about the Laird, and I've been speaking with them at Laird quite a bit lately about this, it's locked down. You don't have root access to this. Now, it has been hacked, and you can get root access, but it's a little convoluted. The process is a little convoluted, and with that new firmware that came out, a week and a half ago, it's not guaranteed you're not going to break your router by doing this process. But that does allow you to SSH in, and there's not much memory on it, so you're not going to be installing much software on top of it.
Is
but
there some type of
you get logs. You can do your own logging. You can feed those logs into your own management system. Laird, they do not provide any interface to your logs except this web interface that kicks you out after like 4 minutes. And it's maddening when you're developing, and that's the only access you have to your logs, and it keeps logging up. They're going to change that in the future. So yeah.
What other gateway you would recommend?
What's that?
What other gateway you can recommend? Other gateways other than this brand?
Yeah, it depends. If you want to build your own, RAK Rack Wireless has a very nice shield that you can get. It's relatively low cost. I think it's under $200. And what's that? RAK Wireless. Yeah. This is the microchip gateway. It's pretty much functionally equivalent to this Laird over here.
Are the gateway chipsets different than the client chipsets? Can a client become a gateway? Client device?
Yes, and no. I can't. I mean, like I say, all of these can be one channel gateways, but I can't put 8 of these together and make an 8-channel.
How much did you say those are?
I just ordered 10 of these radios last night for $55 maybe. $55 and 2 weeks.
AliExpress, or?
Yeah.
$50 each.
Yeah.
Or what?
No, 50 bucks for a lot of 10.
$5 each.
You can get them through DigiKey for about 25, but they're just stocking Adafruit. So, yeah, Adafruit, I think they sell for 20 to 25 bucks.
You can get also this one from Microchip is like $14 or $16.
I don't know. That actually came. That's called a moat, and it's just a little testing.
No, but if you want to just buy the
Oh, yeah,
you can just buy this.
That's 17, I think, is what they're selling them for.
And it shows you are.
When you say $5, just the whole thing or just the little one?
It's just this little radio. Like I mean, then I had to buy all the circuitry on the back.
This is
Part of that.
okay.
This
This is the one you talk about. $5.
Correct. That's just that square word right there. And you'll see that it's also like on
just
those guys.
Yeah.
It's on this ESP30. No, actually, sorry, it's not. That uses a different.
What about this one?
This is a multi-tech MDOT. And the interesting thing about MDOTs is you use something called mbed, MBED, which is an online programming environment. It's kind of like platform. It has a web interface, and it's very easy to use.
What's that? LoRaWAN or something?
You can use Node-RED on any of this. I mean, that's really not tied to a device.
Not on the chip.
Oh, well, on these guys, you could run Node-RED. I mean, if you wanted to.
Oh, the pod. They're on the pod.
Yeah.
Move the.
So this is a gateway?
No. This actually has a chip that allows you to run software against this radio module. It's just this. Just
that's
that
the radio, yeah.
That's the development board.
This is the one.
This is radio.
This is a development board that has, it has an Arduino, like breakout shield, like that other one that was, over there.
This is the one we're talking about, right?
Mm-hmm. The neat thing about those is they have different shields that you can just kind of, pop on. What's that?
I just got one of those in today.
They're very cool, man.
Wemos?
Yeah, I've never used one, but
Pretty cheap.
Yeah, I got a number of shields for them a while back, like an SD shield, a LiPo shield, like some cool stuff, man.
So the Things Network, other than the CAN, what else do you have in there? You don't have other applications like AWS,
Yeah. I mean,
you have some?
I pulled up the AWS
I just use
dashboard. What do you want to see?
My question is, does Things Network give you everything you need pretty much? Do you have a strong need using AWS?
I find for very simple things, I guess you can use it without a cloud backend, but you're going to need some type of cloud infrastructure.
Things Network is not cloud, it's supposed to be like 1 day.
Yes, you can have 7 days of data retention on the Things Network for no cost, and you can make a dashboard out of it.
So you have to choose a cloud background.
if something could happen with this, like with Wi-Fi.
You have to choose a cloud.
Technology.
No, you don't have to. I mean,
in that case, you only have 7 days storage, right?
well, less used to it. I can have a Pi serving as a gateway. I can have a Pi as a
The
server.
cool thing about this is that you can route your message on your own stuff and you don't have to use the Things Network. The Things Network is something free to route messages.
Yeah.
You can just make your own server and you can just do post commands or get commands from that device to your own server.
But once you get the data, it's
Yeah.
just like any other system that you would have acquired data from.
Yes.
And so that's where you have to have your application.
The cool thing is that the TTN is already there, it's built already,
Yeah.
it's free to use.
They have systems set up within the server architecture to do the routing.
Yes.
You don't have to do like large scale routing between groups of servers and gateways, and that's handled. The authentication is handled, the encryption is handled. And so.
So this